1, it's Justin again. So here's the deal. There are 6 attractions on this beach. A candy shop, Lookout Point, the tide pools, a roller coaster, the arcade, and a souvenir shop. I want to see everything before Mia and I have to go home, but I don't want to waste time going back and forth. If only I knew the best order to visit them in. Oh, good point, Mia. If we figure out the order of these locations using what we know about number lines, we can plan the perfect route across the beach. Today, we're going to put together everything we've learned about number lines, rational numbers, absolute value, and inequalities to order a set of numbers. By the end of this lesson, you'll be able to organize a set of values in both ascending and descending order. Let's get into it. Okay, so this number line map says our current location is 0. I think the best route would be to go down to one end of the beach and work our way to the other end. So let's start on the left side and figure out the order we'll pass each attraction along the way. How can I put these locations in order? I think it would be helpful to put them on a number line first. Looking at the locations of all the different spots I want to visit, it seems like some values will be easier to plot than others. Which values might be more difficult? Fractions and absolute values might be a bit harder to plot right away. How can we make these values easier to plot? Yeah, we can identify the absolute value and convert the fractions to decimals or mixed numbers. Pause here to complete those 2 steps. I'll be using decimals. Go ahead and check your values. Expressed as a decimal, the location of the candy shop would be at -1.5 on the number line map. The lookout point is at the absolute value of -1.8, which is positive 1.8. The tide pools are at 0.5. And the arcade will be located at 1.2. Now that all of our locations are written in equivalent decimal form, we're ready to plot each one on the number line. Go ahead and pause while you plot and label each point on the number line. Here are all the points labeled on the number line. Go ahead and check your work. How does representing each location on the number line help us put the whole group of values in order? Right, we know that the farther to the left a value is on the number line, the smaller it is. And the farther to the right it is, the larger it is. Using a number line to order a list of numbers is very similar to using a number line to write an inequality. But instead of comparing just 2 values at a time, we're comparing a whole group of numbers at once. I want to start at the attraction all the way to the left and walk until I get to the attraction farthest to the right. Using what we know about how values increase and decrease on the number line, would we be putting these values in ascending order from least to greatest, or in descending order from greatest to least? Well, since numbers get larger as we move to the right on the number line, we'll be putting these values in ascending order. Before we do that, it's important to note that while we put all of the locations in their equivalent decimal form before plotting each point, that was just a tool we used to help make our work more straightforward. When we're ordering rational numbers, make sure to use the original numbers in the list. So, what's the smallest value on this list? It's the one farthest to the left, which is -1.9. Next is -3/2. Pause here to finish ordering the numbers from least to greatest. check your list. Now that we have the numbers in order from least to greatest, or ascending order, we can figure out what order we'll pass the attractions in. Where will we stop first? Right, the souvenir shop. What's next? Yep, the candy shop. Then we'll hit up the roller coaster. After that, we'll visit the tide pools, and then stop by the arcade. We'll end our walk at the lookout point. Using the number line to compare all of the locations and figure out our route made it super clear to see the order of everything. Is there any other route we could take that would allow us to see everything without having to go back and forth? That's right, we could start at the lookout point instead, working our way from right to left until we end at the souvenir shop. How would that route impact the ordered list of numbers? Exactly. It would be written in the opposite order, which is descending order, from greatest to least. Pause the video here to answer the following questions. First, describe ascending and descending order. Second, how is a number line helpful when ordering numbers? You can write, draw, or add to your notes in another way that works best for you. You might have written something like, ascending order means ordering from least to greatest, starting with the smallest value and moving from left to right on the number line. Descending order means ordering from greatest to least, starting with the largest value and moving from right to left on the number line. Feel free to pause if you'd like to change what you wrote in any way. Let's practice with a whole new set of numbers. Arrange the following values in ascending order. First, plot each value on the number line in your guided notes. Remember to identify any absolute values before plotting. You may also convert all of the values into an equivalent form if you think that'll be helpful to you. Then, order the original numbers. Pause while you work. Here are all the values on the number line. What does it mean to list the values in ascending order? Yeah, it means to list them from least to greatest. So, which value in this set is the smallest and therefore goes first? That's right, negative 3.6. It's the value plotted furthest to the left. Make sure each point is plotted accurately and considers which integer it's closer to. Negative 3.6, for example, should be plotted a bit closer to negative 4. Working our way to the right and toward the larger values, which number comes next? Yeah, negative 11 fourths, or negative 2.75. Then comes negative 1/4, or negative 0.25. The next value is 4 fifths, or 0.8. Next up is 2.5. And last on the list, with the largest value of the group, is the absolute value of 6 halves, which is positive 6 halves, equivalent to 3. Now we have the full and complete list of values in ascending order. Nice work. Let's try one more to make sure you've got it. Here's one last set of numbers. First, plot each value on the number line in your guided notes. Then, order the original numbers, this time in descending order. Remember to identify absolute value and convert all values into an equivalent form, and feel free to look back on the first two examples for extra support. Pause while you work. Check your answers. Which number comes first in the final list? Remember, this time we're listing the numbers in descending order, which is greatest to least. So the biggest number goes first. That would be the absolute value of negative 7 over 2, which is positive 7 over 2, or 3.5. What's the next value? Right, 8 over 5, or 1.6. Then it's the absolute value of negative 1.1, which is positive 1.1. Now we're on to the negatives. What's the largest negative value in this list? Yeah, negative 0.2. Of all the negative values on this list, negative 0.2 is the closest to 0 and the farthest to the right. Second to last on this list is negative 2.75, and the smallest number on the list, also the point plotted farthest to the left, is negative 14/4, or negative 3.5. Together, we now have the full and complete list of values arranged in descending order. Great job! Thanks to our expertise with negative numbers, number lines, absolute value, and inequalities, I don't have to go back and forth a bunch of times to check out everything I want to see at the beach. Don't forget to complete the practice activities for this lesson. In the meantime, me and I are gonna snag some scooters and ride down to the souvenir shop so we can start exploring. See you next time!